I think it's Giant Studios. Let me make sure. Shit. It's Giant Studios? Universe Sandbox 2. By Giant Army. Alright, we'll have to restart that. Hello everybody, it's SkyleKid here, and today we'll be playing Universe Sandbox 2 by Giant Army. I just downloaded it from the Steam store, and we're gonna have some fun with it. So here we are, we're in this universe, our universe, obviously. And if we zoom in real close, we can see our own planet Earth. Here it is, right here, Earth. Sweet. Let's zoom out, get back out to the to our solar system. So we got the Sun, got Mars, Earth, Mercury. Right now we're moving at about 1 second per second, so like real time. So this is what the universe would look like in real time. Obviously everything is really small in comparison because everything is kind of like real size. So let's speed things up so we can see some motion. How about that? Let's go for 1 hour per second. Let's see. Here we are. So things are gonna start speeding up a little bit. It probably won't be too much actually, because 1 hour per second really isn't a whole lot. Anyway, now you can start seeing the Earth rotate. So 1 hour every second. So obviously the Earth's rotating pretty quick. Let's even bump that up a little bit more. Let's go for 1 day per second. So things are gonna start getting a little fast here now. So here, holy crap, there we go. The Earth is really rotating. 1 day per second. So zoom back out, we can actually start seeing the orbits of the planets, which is pretty cool. Let's even bump it up again, 1 month per second. And obviously this is like a simulator type game, so everything's supposed to be trying to behave accurately as far as physics is concerned and whatnot, which is pretty cool. And we're gonna play with some cool stuff. We can modify some properties of the different planets and things and add planets and see how it affects the universe. It's gonna be a whole lot of fun. Let's slow it back down again. Let's say 1 hour per second. That was probably pretty good. Because we're going to try and do some things with Earth. And again, I haven't really played this game too much, so as far as how things work, it's a little bit of a learning curve for me too. So if we click on Earth, I believe we can start editing different materials inside of Earth. Oh shit, what is this? So I guess we could edit the poles and the axes and things. Let's not play with that right now. I'm trying to get into it where I can edit the materials. There we go. Alright, so name is Earth, obviously. Mass, we can increase, we can decrease, we can do all kinds of stuff. Age, we can edit all this stuff. Surface temperature. Alright, let's see what happens if, say, like, there was global warming or something. Let's start increasing our temperature just very slightly. Let's see what happens. Actually, we're decreasing temperature, aren't we? So look, the Earth is starting to freeze over. Very slightly. But it is freezing over. Let's keep going. Let's, even more. It's gonna turn into an ice planet very soon here. Holy crap. Just keep going. It's freezing over. It's becoming a big old ice ball. Holy crap. Let's do the opposite. Let's say 100 degrees Celsius. What's gonna happen then? I bet you the oceans are gonna start boiling off. Let's see, if we keep on going, what's gonna happen? See, now we're decreasing, so no, now it's gonna get cold. Alright, let's increase actually. Let's decrease and increase the same exact thing. Let's go to 150. Boosh. Alright, so we're losing some of the greenery because it looks like things are starting. Oh look, the water looks like it's starting to evaporate. Look at that! The water's starting to evaporate. Holy crap. It's starting to become a planet where there's no water. Wow. I guess that's the ocean, the Marriott Trench maybe, right there. Still some water though. It hasn't all evaporated. Alright, let's bump it up a little bit more. 200 degrees Celsius. What's going to happen now? Oh yeah, look at that. We're starting to lose the rest of the water. It's become a barren rock with very little water. Very dry. No plants are probably surviving. Let's even go further. 300 degrees Celsius. What's going to happen now? I don't know if it's going to start catching on fire yet. Probably not. Probably have to get pretty high. But look, it's even getting browner. Well, even more. Holy crap. 500 degrees Celsius. What's going to happen now? Oh, here we go. Now it's starting to catch on fire. You can start seeing there's wildfires burning out. A little bit of magma on the surface. It's pretty hot. 900 degrees Celsius. It has become a burning planet. No longer capable of sustaining life. Tectonic plates are probably melting down. Continents are no longer what they seem to be. Holy crap. Alright, so let's jump it back down to 100 and see if it can regain its shape or not. Probably not. The continents are still there. If we keep on going down, I don't know if water's going to reform. Oh, it does. So water has begun to reform. Plants are starting to regrow. Things are starting to take their shape again. So now we're kind of back to how we were, I think. Let's go down to like negative 1,000 degrees. It's probably just going to become a barren ice world where nothing can survive because everything is completely frozen. And as we can see, it's starting to get lighter as the water freezes over, becomes ice sheets. Nice. Alright, so what's the normal temperature? Like 24 degrees or so Celsius, about the average temperature of the Earth. We'll jump back to normal because we're done playing with that. So, rotational period, we can increase or we can slow. Let's say instead of 23.9 hours per day, let's say maybe 2 hours per day. Holy crap, now we're really spinning, aren't we? Let's say 900 hours per day. What's going to happen when all of a sudden one part of the Earth is getting all the heat from the sun and the other part is almost entirely in shadow all the time? Where'd I change that actually? I think it was rotational period. Anyway, we'll keep that how it is. 35.7 days. 37.5 days, sorry. So is the back end going to start freezing over? Kind of looks like it is, isn't it? I think the back end's starting to freeze over. The front end here is probably getting really, really warm to the point where it's not going to be able to sustain life. It's getting all of the rays of the sun. Yeah, look, it's freezing over back here. Alright, display mode, elevation. Oh, look at this. You could even see surface features and stuff. It's pretty cool. Alright, so I mean, we're having fun. We're checking out the different things that we can do. Let's switch it back over to 23 days, actually. No, it needs to be auto. Is that normal now? I think auto might put it back to its normal state. Alright. Anyways, what else can we do? Surface gravity. That could be pretty cool. Let's bump that up to like freaking 900 if we can. Actually, can we even adjust that? I don't know if we can. And I don't know what this chart is doing either. I guess surface gravity is dependent upon the mass and everything else. So probably can't mess with that. Eccentricity. What does that mean? I don't know what we just did. What did we just do? Oh shit, I think we've just messed with the orbit. Yeah, we have. Alright. Alright, Earth, we've messed with your orbit. I do apologize. Inclination, all this good stuff we could play with. Alright. Let's not mess with that. But we can mess with the mass. So let's bump up the mass, see what happens. So if we keep on increasing the mass of the Earth, what is going to happen? Everything's going to start changing. The days are going to get longer, the planet's going to get larger. Rotational period takes longer because it's larger. Everything's going to change. Escape velocity is increasing. The size of the Earth is just continuously growing. Holy crap, is it growing. Let's go with the 100. What's that going to do for us? The planet is getting quite large at this point compared to other planets in the solar system. We're going to start affecting gravity of other planets very shortly here. Everything takes a toll. Everything has an effect, you know? So let's go with like 10,000. Holy crap, it has become a gas giant, I think. I do not think it can sustain itself any larger than what it has become. So if we go to display mode and look at elevation and surface features, we can't even see anything. Unless this is just a blank model until the Earth gets the actual size. But I'm kind of doubting that. I think it's still growing. It is still growing. Alright, what happens if we bring it up even more? Earth 3.51 Jupiter. I don't know what that means. Mass? We're going to go with like 9999. What happens then? Holy shit. Something pretty crazy just happened. It's become a giant nova. Holy crap. It has now encompassed the entire solar system. It's just a big old gas and still expanding. Look at this. Expanded way past the galaxy at this point. Things have become pretty crazy. The mass has increased so much. Look at this. Earth nova remnant. It's some kind of like black pulsating mass. Don't even know what's going on now. Holy crap. That is intense. Is it still growing? I think it might actually be. Alright, mass. Look, it's 1.25 sun. What about Milky? What happens now? Let's go with... Let's increase this to like 10. Now what's going to happen? Holy crap. We have done something pretty crazy at this point. It is so large, there's just no longer anything to even see. I think it's a black hole at this point. Wow. I don't even know what this is. This must be like energy blowing out the sides of it. Who knows? Anyways, I think at this point, the Milky Way solar system is done. I don't think there's any more things that can be done with the Milky Way solar. I'm zooming out. There doesn't seem to be anything left. Holy crap. I think it's time to start a new simulation and start messing with other things. Let's go back to our solar system. Normal solar system. Here we are, back at the normal solar system. We're moving quite quickly. As you can see, we're moving at about 350 hours per second. Let's change that to days per second, and let's go to 1. You can that's a pretty good speed, right? Gives you a good idea of what's going on in the universe, how things are going. I like it, alright? So let's see, what do we want to add? We can start doing different things. Let's not go with the edit mode, let's go to add a body. So what happens if we throw in, like, hey, like, a sister Earth? What happens if we throw in a sister Earth right here along the path of, where is Earth, actually? There we are, there's Earth. Right along the path of Earth. We just gotta get our pointer correct here. So boom, we just got another Earth. What's gonna happen? At this point in time, it's kind of just there's no rotational velocity. It's just going straight in towards the sun because it doesn't have any rotational mass. So what happens if we go back to this Earth now, which is flowing straight towards the sun? There's nothing that can really even be done. Eccentricity. You might be able to make it so that it can start orbiting. There we go. If we down to 0. Inclination, we probably want 0 as well. Alright. So we've completely altered the path of planets. We've added a new sun, a new Earth. Over time, things are going to really change. Here we are. Let's look at the sun. We haven't really looked at the sun. This is something fun to play with, right? So the sun. If we increase its mass, what's going to happen? Let's say we increase the mass from 1 to 2. Let's go. Try it out. 2.0. So now the sun has become twice the size that it normally has become. What's going to happen to these planets? What's going to happen to these different rotations and things? Let's find out. Let's increase our speed to 10. Maybe a little bit more. Let's go to, like, say, 50. So now everything's spinning pretty quick. Everything's going to be thrown out of whack. Mercury, Earth, nothing's in it. Everything's spiraling out. Look at this. Actually, let's restart this because we don't want to have that extra Earth. Because we want to see what happens exactly if we just mess with the sun's mass. So if the sun increases mass to, say, 2.0, what's going to start happening to these planets? Look, Mercury has flown out. The mass is so large. Oh, it's going to collide with Mars. Holy crap. We've just entirely changed the whole dynamic of our solar system by increasing that mass. By doubling the size of the sun, it's just too much. All right, anyway, sun. We're going to increase this to like 20. It's 20 times its normal size. Look at this. It's so heavy now. Boosh! Everything's going to start colliding into the sun. We may have... The issue here might actually be that we don't have collisions on. Alright. Simulation collide on. They're on, right? Gravity. They're not. They should be colliding. The sun should be sucking stuff in at this point. Which it doesn't seem to be doing. Unless these things are getting so close they're not actually getting sucked in. What's going on now? They should be able to collide and get sucked in. I mean, that's what I would think. Have we lost any more? Look, Mars, Mercury, Earth, and Venus have all gotten past the point of no return here. So let's add a Jupiter. Let's see if this thing can actually get sucked in. So if it can't, that's going to be pretty stupid. Oh shit. It just got like instantly sucked in. Alright, we need to slow down then. Let's go with 1 hour per second again. So everything's been slowing down. Alright, there we go. Now we have a Jupiter. Jupiter should be going to get sucked into the sun. There we go. And keep in mind, we're only going at 1 hour every second. So here it goes. It's moving really quick at this point. Holy crap, is it moving? Boosh! Look at that. Let's add a bunch. We're adding mass every time this happens, too. We're feeding our sun with a whole bunch of Jupiters. The mass of the sun should be... Oh, yeah, look at this. We've entered the point where it becomes a supernova? Is that what this has become? A nova. Everything's been thrown out by the energy, too. No longer is it sucking things in. Its mass has become to the point where it's just throwing things out with all the energy it's producing. It's crazy. Wow. How awesome is that? Pretty awesome. Alright, what happens if we start messing with this now? Let's get out of this editor. Let's look at our sun nova remnant, right? What happens if we decrease our surface temperature down to 0 Kelvin? It's going to lose a lot of its energy. What's happening now? We've decreased the temperature down to 0 Kelvin. It once was a very, very hot supernova. I'm not even sure what it is now, to be honest. Let's lower our time frame here. Minutes per second. Let's go with 1. Oh shit. I messed something up here. Let's go with 1 second per second, real time. We're in real time, but wow, it's still like really moving. I don't even know what's going on at this point. I don't know if we broke the simulation or what. Anyway, let's look at the Earth here. What happened to Earth? Earth is a giant fireball at this point, which I guess makes sense. We better restart the simulation. All right, let's restart the simulation. Go back. Here we are. We're back. Oh, hey, how's it going, Madkill? Thanks for joining us. So here we are. We're back in the simulation. This is our normal solar system. Everything's back to normal. Everything's fine. What happens if one day the sun goes out? Holy crap, what happens? Let's set our simulation to 1 second per second, real time. It takes a couple seconds for things to die down. Let's check in on the Earth first before we get any closer. So here's Earth, here's us. This is our home world. We're just having a good old time here, floating around in space. Pretty insignificant compared to the universe if you think about it. But here we are. I live somewhere right around here. I don't know where you guys live, but that's me, right around here. Anyways, all of a sudden one day, the sun here is going to take a crap. So we're going to lose all of our surface temperature. It's going to go from 5,775 K to, say, 0 degrees Celsius. All of a sudden. Did that take effect here? 0 degrees, please. Oops. Celsius. 0 degrees. Enter. Is this not working? 1 degree? It's not letting me. Why are you not letting me? Huh. Let's try 50 degrees, Kelvin. You don't let me change this at all? It does not allow me to change this. It could be because of the mass and density of the thing. Maybe it won't let you actually lose. I don't know. It's odd. Alright, let's change some other parameters here then. How about... got some stuff that's locked in. Maybe that's... could that possibly be? Surface temperature, I want it to go down. It's not letting me. I don't know why. That's a little upsetting. Display mode. HMI. AIA. I guess this is different types of satellite probes they send out to do different things. Anyway, surface gravity, rotational period, what else do we want to try messing with? I did want to see what happened if the sun died out and lost all of its energy, and how that would affect Earth. In this simulation, of course. Density, we could mass 1 sun. How about we do 1 Earth? Then what happens? Mass 1 Earth. What has happened? I think we've entirely thrown our whole thing out of whack here. The sun is now just mass of 1 Earth. Surface temperature, yep. See, look, it lost its surface temperature. I bet you it had to do with mass. Let's check it on Earth. Earth, how you doing, buddy? Earth looks like it's slowly starting to freeze. Look at this. These mountains here, they're starting to get pretty cold along the coastal cities. We can see some white. No longer are we getting that that heat from the sun. And look, there's no more light as well. I bet you in about 7 minutes we're going to lose all the light coming to Earth here. Things are getting really cold at this point. Let's increase speed a little bit. Instead of 1 second per second, go 1 minute per second. It's a little more realistic. So what's going to happen? Time step. We should be moving at 1 minute per second. I think we are. Let's go even a little bit more. 1 hour per second. There we are. We should lose our light, unless the simulation doesn't account for that, but it should. So let's just start freezing to death with no heat from the sun. What's going to happen? Just wait and find out. Got some snow coming around here in South America. The Americas are slowly starting to get some ice built up down there. Let's increase our speed to, say, 20 hours per second. So things are moving pretty quick at this point. We'll let the simulation play out for a little bit, and then let's slow back down again. So what's happened? Europe, Asia, starting to freeze. Africa is still, for the most part, its former self. The Americas are starting to freeze even more. You can see over here towards the Utah, Colorado, California, they're starting to get pretty cold. Canada, as most of Canada, the western part, has become a frozen wasteland. And let's let the simulation run for a little bit more. Moving pretty quick at this point, and we'll drop back down. Most of Western America's been frozen. Europe, Russia, all this areas over here in Europe have become a frozen wasteland. Let's go again. Let's move pretty quick here. And then we'll stop, say, now? Yeah, now most of the world is started to become covered in ice. It takes a little while, but it's this is where things have become, because we've lost the power of our sun to keep things warm. Almost the entire United States has become a frozen wasteland. Let's increase it even more. Say 900. Things are going to be moving pretty quick at this point. We'll let it play out for a bit. And, alright. We'll stop it. Looks like most of all the continents on the Earth have become frozen over. You can see the tip here of South America has become conjoined with the southern hemisphere. There's land bridges probably everywhere at this point, just from ice. Yep. You can see even over here where Alaska once was, is now conjoined by ice over here to the European nations, Russia and Japan and all that. Africa has become a frozen wasteland as well. If we increase it even more, sooner than later, I bet you the oceans will start freezing over as well. It just takes some time. So let's stop here. Looks like most of the Earth has now become a frozen ice ball. That is, of course, because we've lost the power of our sun to keep things warm. Which is a shame. If we ever lose the power of our sun, our planet will freeze over, we'll lose all of the light coming to Earth. Looks like things are starting to get dark. And that's going to be the fate of our world one day. Though it probably will just get swallowed up by the sun. Which we can simulate that as well, which could be pretty interesting. So there we are. Let's go back to the sun, return things back to normal. Though I think, yeah, looks like our solar system has been thrown all out of whack, because of course we don't have the same gravity that we used to have. Let's reset the solar system and try something new. Alright, Mr. Sun. So let's see. Things are going along pretty well here. Let's go back to, say, 1 minute per second. So pretty much a solar standstill. Nothing really much is happening at this point. So Mr. Sun, what's going to happen? You're going to start turning into a red giant. Let's see if we can possibly simulate this somehow. So your orbit, I don't know what these things are for. Like I said, I haven't seen a whole bunch of stuff. Oh look, we could actually change the material inside it as well. It's pretty cool. Let's see. Anyways, let's go to motion. Basic. Alright, basic's fine. So how are we going to do this? Density would probably need to change, right? So density would decrease, I think? Maybe? Let's increase our simulation speed to, say, 10. That's probably not going to be enough. I guess minutes per second, we can go to hours per second. We'll go for 1. Might be better. Things moving yet? No, how about 10? Alright, that's pretty good pace. So our density is decreased in the sun. So the sun should start growing. If the mass stays the same, the density decreases. It should start growing, correct? Let's find out. 0.5. Does not let me change this density, though. Why don't you let me change this? We could change the age and let it progress normally. Look at this. Now it's starting to increase. So, sun, as time progresses, you'll become larger. Eventually, what, are you going to turn into a nova? What's going to happen? We're increasing the age of the... And days? No. Let's go years. We better restart this. I think I messed with the sun too much. Alright, sun. You've become your normal state. Your age is 4.66 G years. Let's see about increasing that. So what's going to happen to the whole solar system when the sun becomes older and older? It's going to become bigger, I think. Because eventually it's going to turn into a red giant, right? And swallow up the Earth. Well, apparently something has been thrown off because the planets have been thrown out of their orbits and they're heading somewhere intense. I have no idea. So we're increasing the age even more. It doesn't seem to be helping too much. Nope. Alright, I don't know what we did, but we messed something up. Let's go back. Something else I want to play with is Mr. Earth here. Let's zoom in on Earth, our good old whole planet. We're going to be coming to Earth a lot. We'll slow down our time because we're moving way too fast. Minutes per second, let's go with, say, 60. That's pretty good speed. So let's see what happens if we start messing with the materials that are found within Earth. So we have minerals. Let's turn up our iron. Well, no. Before we do that, maybe we could start playing with the Earth similarity. Interesting. Magnetic field. Show magnetosphere. So this is the magnetosphere of the Earth, I guess. Sure. Let us increase it. Or actually increase the magnetic field. So what happens if we start increasing our magnetic field? What is that going to do? I'm not even sure what that does. What kind of effect that's going to have on the planet. Is it even having an effect? I don't know. Over time, we may find out. Huh. I'm not sure if that has an effect. Show Aurora Belt. On. I'd like to see the Aurora Borealis. I don't know what the belt means. Alright, anyways. Let's see. Magnetic axis on. Magnetic field. If we keep on increasing this, what's going to happen? What if we just, like, increase this like a shitload? Tesla. Let's go to, like, 5. What did that do for us? I don't know. I know if we lose it entirely, we'll lose our atmosphere, right? Or we'll get hit with solar flares, possibly? I don't know. Alright, Earth. What else do we want to try changing about you? Your materials, that's right. So water. What happens if we start increasing our water? Oh boy, look at this. Interesting. Organics. What happens if we start increasing our organics? Iron. Look at that. You can see the core size and stuff inside. That's pretty cool. Silicates. Iron. Water. I guess everything is a percentage of itself. So we can play with the world, find out what's going on. Oh shit, look at this. Gas. It's becoming a giant gas giant. Wow. I guess at a certain point it just turns. Iron. Let's turn the iron up. So what is Earth? It's about... I have no idea, honestly. Water, organics, hydrogen gas. I'm trying to get back to Earth somehow. I don't think I'm going to be able to figure it out. Silicates? No. Iron? No. I think I may have messed this up. Because now I can't seem to find out how to get the continents back. Oh well. I'll restart. Actually, what's this? What are these different scenarios? Let's check out some of these different scenarios. Like bombardment of the moon. What's going on here? Oh wow. The moon has just been hit. Oh, it's getting hit all over the place. Look at this. Boosh. This is what we can do. We can start bombarding the planet Earth. See how that goes. It's losing mass. It's getting hit. Big old craters and stuff. Nice. Is there still stuff coming towards it? That's what's going to happen over time. Increase this. So what's going to happen to you? You're going to turn red with heat. It's the geothermic activity. And eventually you'll harden and stop, right? Should eventually turn back into a solid rock, I guess. So I guess this is what happened to our good old-fashioned moon. And there we are. Big old craters on there from getting hit. Nice. Cool. What else we got? We'll just try some of these random ones. Sunwolf Jupiter. What the heck is this? What's happening here? Are things getting absorbed by Jupiter? What is going on? Stuff's happening. I'm not sure exactly what. Look, things are getting hit and everything. Boom. Boom. Everything's gonna get eaten by that sun, I think, though. Probably. I don't know. Maybe not. What else we got here? Climate simulation with tidally locked Earth? What? Alright. Okay, what's the simulation? Not sure exactly. Oh, I see. I think the back of the planet is stuck in shadow, and the front of the planet is stuck in the sunlight, by the looks of it. So the back side is going to freeze, while the front part gets exposed to the sun rays the whole time. I think that's what it is. Maybe. Now it's spinning, though. Who knows? What else we got? Binary pulse. That seems kind of cool. Wow. What's going on here? That is cool. Cool, but... Okay, I only need to see a little bit. Earth in between suns. Whoa, we need to slow down here. So it's in between two suns? It is. Look at this. So how does that affect things? I don't know. Not worried about it. Planet, grid, rocky, 3 levels. Oh, what is this? What? How cool is that? Can we have everything crash into each other and see what happens? Because that'd be freaking sweet. Nothing wants to seem to collide. Alright. Let's go with 1 hour per second. Alright. Simulation. Gravity. Will be 1G. 1G. Boosh! Wow. Look at that. They've created one super planet from all of the mass. Nice. Cool. What else we got? Earth, Moon, number 6 collision. Saturn and moons, Kepler system, Earth-like look-alike planets. Let's just go back to our normal solar system. Let's play with Earth a little bit. Alright. Let's slow it down to, say, 1 minute per second, which I seem to like a bit if we're trying to do slower paced things. We'll zoom into our good old buddy Earth, which is kind of like like a standstill here, pretty much. 1 minute per second is pretty slow. If we go for 1 hour per second, it might be a little more. There we go. That's probably a little bit better. And let's see about adding a comet to come in. Let's see. Can we get stars? Okay, common stars, planets, moons, minor. Asteroid. Random asteroid seems pretty cool. Let's add an asteroid into the mix here. Let's slow things down as well. Let's go for 20 minutes per second, which is pretty slow on a cosmic scale. So here we go. We're gonna add an asteroid right here and see what happens. We're actually moving pretty quick. That might be a mistake. Is it gonna even get sucked in? May not. If we had one right there in the path of Earth, might be in better shape. Even moving slow, it's still moving very quickly around the Earth, isn't it? Around the sun, sorry. The Earth moves very quickly around the sun. So here, I guess we don't have enough mass to be pulling these things in. Alright. So what happens if I put one right in front of it? Ooh, that almost hit. We want to see what happens. I guess if we just have the Earth by itself, not in rotation of the sun, can we get just the Earth? The moon, maybe? There we go. Alright, perfect. So it's not moving at all. We're moving at a pretty decent speed. Let's add a random asteroid, if I can find one. Random asteroid, and then we'll see what happens. Is that it right? Let's see right here. So we're going to find out. It's going to start barreling in towards Earth. It's going to hit right around here. I don't know where it's going to hit. We'll find out. Should be interesting. Where is it? There, it's coming. Bailing pretty quick. Boosh! Hit right towards the Earth there. Look at this. It took pieces out. Pieces out of the mantle, actually. Is this going to start filling back in with water, then? It might. Let the Earth take a couple more rotations here and see what happens. It should get filled in over time. Slow down. I don't know. Let's add another one there. Boosh. Keep on bombarding the planet. What happens if we take something like that? Oh yeah, now it's kind of a little more intense. Yeah, at this point, we've pretty much destroyed it. Alright, let's go back to the Earth and the Moon comparison here. Let's say we have the Moon. Where's the Moon? Our Moon. Planets, moons. Perfect. It should just be Moon, right? Moon. Perfect. Here's our Moon. Say it's out here. It's doing its nice little orbit. And all of a sudden, shit, something happened. Oh no. And baboosh. The whole world would just be destroyed. And that would never happen, but you could. Not really. What is going on here? Holy crap. What are all these orbits? Look at this. speed this up a bit. Interesting. I don't know what's going on here, but it is pretty. It's very pretty. Wow. Alright, let's see if there's any other cool ones. See, I haven't made these. These are things that have been made by other people. Anything good? See, there's a lot of dice swarm. What the heck is this? What? Alright, dice. Let's see what we can do. Look, they're becoming larger dice. Smaller dice have all conjoined into one giant dice. Let's add the earth into this, into the mix. Oh shit. I guess the dice were pretty small in comparison. Alright, earth. What happens if there's two earths? Oh no. The earths. Oh, again. They have both combined into a giant super earth. Oh no. Earths. Destroyed. And then Jupiter, of course, is just this giant big old ball. We have 3 of them. Boosh. What happens now? Becomes a super spinny ball, apparently. Eventually, they're going to become large enough to become probably a sun and then a black hole, I imagine. What's going on over here? Why does everything get sucked over here? Let's make enough mass right here. Everything eventually will get sucked back if we make enough. Come on. Eventually, that should get sucked back. This is getting pretty big. I don't know what we're making with all these Jupiters. There we go. Maybe they're getting sucked back now. Why are you taking off in that direction? Rings. I don't know what we're doing with this. It is no longer Jupiter. Spiral Fiat. Grid 2D. I don't think we're doing anything with that. Alright, objects. What do we got? Basketball. I don't think a basketball has anything... Is it a real size basketball? Because... New Horizons. Because if it is, it's just getting destroyed right away. Teapot. Nice. Galaxies. Oh shit. I think I just added a galaxy into the mix there. Oh, that's not good. I guess it happens. Cigar. Alright, well, we've entirely messed everything up. Look at this. I probably could just keep zooming out. Holy crap. How far does it go? I guess it just keeps going forever. It does seem to just go forever. Yeah, well. Ooh, and now we'll go back in. Alright, well, hey, that's pretty cool, right? Let's go to one more. Let's pick one more. Earth and Sun. Comet test. That sounds cool. Alright, comet test. I don't know what's going on. Comet, comet, comet. Okay. What's the point? Is anything even moving? There we go. This comet's supposed to go eventually into the sun, I guess? Oh shit. We've gone very quickly. This comet is in a stable orbit? Is it in a stable orbit, or is it slowly losing its orbit? It's hard to tell. Alright, before we leave, we'll do one more thing. Fiction. Supernovas. I guess there's different stuff you could do. Human scale. Orbit bowling ball. Historical. Exoplanets. Planets. Solar systems. All. Let's just do our solar system one more time. And just for the fun of it, let's see what happens if we put a black hole right in the middle. And that's where we'll end off. So let's add a big old black hole. And we'll do it in real time, too. Let's do it in real time. Seconds per second. We'll do 1. I mean, we can have our sun become a black hole, which might work. I'm not exactly sure how you would do that. Density would have to just skyrocket, right? So we've increased the density to some insane number. And surface temperature. Let's also increase the mass. So this should definitely start becoming a black hole. Sun nova remnant. That's definitely a black hole, right? Oh yeah. Sun. It's gotta be a black hole. Sun nova remnant. I think it's starting to increase the size too. Alright, so no one really knows what's happening here, right? Everyone's just kind of like, oh no, the sun, it's become a black hole. And that definitely looks like a black hole to me. But I think it's also radiating some energy out of here. So as far as things go, everything's still kind of normal. I mean, you wouldn't even know for 7 minutes or however long it takes for light to reach Earth. Let's speed up time a little bit. Let's go with 2 seconds per second. So now things are moving out. I mean, this is moving very fast as far as things are concerned. I mean, look at this. For every 1 second, 2 real seconds have passed. For every 1 second of real time that we're living, 2 seconds move in the simulation. And this is just moving out from the sun. So what happens if we go to, say, 5 seconds every second? Things are moving much quicker now. Obviously, orbits are going to be changed. Orbits are going to be affected, but I think this gaseous cloud are going to absorb some of these planets. 10 seconds every second. 20 seconds every second. It's pretty intense. It's going to swallow Mercury here very soon. 50 seconds per second. Goodbye, Mercury. Nice knowing you, buddy. We'll just let this take its course. We'll see what happens. Things are really moving at this point. I don't know how this is going to affect Mercury. Just kind of like hanging out here. I mean, this is what you would see if you're on Mercury. And I think Mercury has become a giant steaming ball at this point. It's becoming absorbed by whatever this cloud is. This energy is just reaping past it at such intense speed that the whole front part here is just being completely destroyed by heat and pressure, I think. I mean, I don't know. I'm not an astronomer, but I would assume that's what's happening. Looks like at this point, it's already passed out towards Earth. Earth is probably now starting to... Well, Earth has probably already received the brunt of this. If it hasn't, it's going to very soon. Oh yeah, Earth is going to get decimated here very shortly. It's coming. The cloud is expanding outwards. Wow. I don't know what's going to happen. I'm excited to find out. I don't know. Mercury, sun remnant is that way. It's being taken over by the cloud. So the sun remnant is over there, and we're no longer receiving light from over there because the sun is gone, I assume. So I guess we're just receiving light from other galaxies or something. Oh, the Earth does seem to still be in decent shape. It's still hanging on here. Nothing really has happened to it. Maybe it's the its ability of its magnetic field to keep it safe. I don't know. Let's increase the speed a little bit to 60. Maybe to 75 even. Because maybe the brunt of it just hasn't hit yet. Not sure. I'm not even sure what's going on. About 100. Eventually something's going to happen. Everyone's still feeling pretty good in the United States by the looks of it. All the lights are still on, so people are still alive, I assume. And we're way within sight of this, whatever this is by now. And I don't want to miss it. We can increase the speed a bit more to 200. So something should start happening here, right? What's this? Hawaii, maybe? I mean, at this point, the planet's also going to start freezing, right? Because we're not getting the heat from the Earth or the Sun, I would assume. I don't know. Let's increase it to 500. At this point, this thing is going to be overtaking the Earth pretty quick. I'm very surprised the Earth is still okay. This would be pretty incredible to look up and see, though, if you were on the planet's surface looking outwards. I don't know. Is this a wall of energy that's going to be hitting the Earth very shortly here, possibly? We'll find out. I don't know what's happening. We're definitely well within this cloud. Like in the center of it pretty much now. So I guess it doesn't really have an effect. How are our orbits affected, by the way? As far as everything's concerned. Everything still kind of seems to be orbiting around as normal. Things are normal, things go. Alright, this is definitely a black hole at this point. Alright, can we increase the density possibly? Let's change this from sun to galaxy density, increase it to 0.005. That's going to be pretty intense. It's going to be pulling things in. Alright, let's increase it to the mass of 1. 1 Milky Way galaxy. It now has the mass of, which is very intense. Alright, Earth. How are you doing? Earth seems to still be doing alright. At this point. I mean, as far as sustainability, I don't know. There's no lights on the other side of the Earth now. Everyone possibly could be dead. I don't know. I don't know why the lights aren't on. I don't know what's going on. At this point, all we know is there's no lights on Earth anymore. So, possibly, whatever's going on can't be good. The surface temperature is 41.5 degrees Celsius. That's pretty high, right? Alright, everything's still fairly normal. Rotational period's normal. Surface gravity is normal. But there is no lights on Earth anymore. Something must have happened. Alright. Where are you, sun? Jupiter, how you doing? Jupiter is really hot, apparently. It's like glowing red. I don't know what's going on with Jupiter. Mars, where's Mars? How you doing, buddy? Mars has become an inferno, somehow. And how has good old Earth survived this, then? Is it the magnetic field, Earth? Is that what has kept you safe? What happens if we drop your magnetic field to 0, Earth? Oh, Earth, something's happening to you, buddy. What's happening to Earth? Look, something's happening. It's starting to, like, boil or something. Something's happening. Look, we're losing all of our... Oh, yeah, look at this. We're losing all of our water. It's becoming a... Oh, shit. It's becoming like Venus. Like a burning inferno planet. Wow. I don't know what exactly happened, but... It's not looking good, Earth. Alright, Earth is definitely gone. No more Earth. Alright, Sun Nova Remnant. You ready for your bump in mass? We're going to go to 50 Milky Way density. That should be enough to suck some crap in. Actually, no. You know what? Let's go big or go home. Let's go to like 1,000 Milky Way density. Let's actually go back to the normal solar system and do that, actually. What's going to happen if the density of the sun gets so dense that just crap hits the fan, probably? No, we don't want that. We want 10,000 Milky Way galaxies, but before we do that, we need to slow down speed of time. Oops. Well, apparently that's what happens after a very long time. But we don't want to see that. We want to see it in like real, almost close to real time. I mean, like it's a perceivable amount of time as far as we're concerned here, right? So maybe an hour a second would probably be good. That'd probably be decent. All right, so an hour a second. So we want to see these things happen, you know, pretty decently, right? So the sun, your mass is going to go to 9,999. Oh, shit. And shit has already hit the fan. Alright, well, fine. Earth, how are you doing? Earth is obviously fine. Well, no, it's not. It's burning up. Okay. We cannot take the increased mass of the sun. It's just burning us up. Nice. Oh well. What else do we want to try? If we increase the mass of the sun without increasing the temperature of the sun, I mean, I don't know how that would work. Let's increase the mass to, say, 999 suns. 9,999 suns. Shit. Density would be 9. 0. Actually, no. Density would be 1. You cannot change this, actually. I think density is not something you can change. Age is pretty high at this point. 1 degree Celsius. What's gonna happen? It's very cold, but it's very dense. If we look deep into the center of the black hole, we may find our souls. Who knows? Earth obviously cannot take it. Surface temperature of Earth we've dropped down, but it's going to go right back up. Because it cannot take the heat of that sun. Holy crap, can it not take that? We tried to lower it, but just comes right back up because it's very warm in this cloud of gas that we're in. Which has become quite large. It's sucking everything in, isn't it? It's all stuff that's just getting sucked in? I think it might be. I don't know. Uranus is out here. Should we check up on Uranus? It's very warm. Uranus is very warm. Anyways, I think we had some fun there. It's a pretty cool game to check out. Play around the solar systems here. Yeah. Anyway, it's a fun game. If you guys enjoy this game, it was made by Giant Army, I think, right? That's the name of the developer. It's pretty cool. It's a pretty cool game. If you like playing with solar systems and tweaking little things and playing with simulations, I recommend it. It's pretty cheap. I think it was around $20 on Steam. Pick it up. I seem to have a lot of fun, and I'll probably play this a lot more. So, thanks for watching. I'm Kyle Kid. If you enjoy these videos, make sure you subscribe, hit that follow button, and I'll see you again. Bye-bye.